All right. Hi, this is David for Comp2. This is the program. Let's go ahead, run it. Game 2. So it's recreating a Nintendo game called Shadowgate in C++ because it was written in like assembly, I assume. I wanted a skeleton to work with that already had the logic of a game. It reads, so the game, when it runs, it loads up. Well, here, we'll just walk through a bit. So, welcome to the castle. It has a description of the room, which is in the room object, and you can go left. We can't go left. In this case, we can only go forward. Above the wooden door hangs a skull, so the minimum viable product for this game currently is just the first room. So we look at skull. So there's a text parser that is parsing out look as a verb, skull as the object, and there's no third thing because I don't have that yet. It's parsing it, but we didn't do a third thing. So inside we see a small key. I'll show that in a minute. Is changing the state of the skull. Well, actually, it shouldn't change it now. What if we look at the skull again? Aha, it worked. Cool. Let's take the key. We have the key. Now, if we look at the skull, it changed. So the skull is now empty. So those are room object, player object, key object, and skull object. And then we go forward, and also back works. Also go forward works. So now we're in the next room. Old columns rise in the darkness. Spooky castle. And I do have the entire map. We can go right, which is a little closet. We can go back. Go back keeps going back to the previous room. Go forward. Ancient altar. Go forward. Long hallway. Go forward. Dust coats row of ancient coffins. Go forward. Tall mirrors. We can go left. We can go left. Go back. So there would be objects in the room with their own logic, but that's the MVP currently, is interacting with the objects, the key object, the room object. I'm doing this at the end, but I'll probably put it at the start. Real quick rundown of how it works after I showed the first walkthrough is main calls the room load function, which goes to room.cpp file, calls the room loader function, which makes a map string of room pointers, of room objects, room pointers. Opens the file rooms.txt, tests that it works, try catch, using some bits. Could have done it differently. So we make a struct of the exits to hold language for the pointers. For all the rooms hold 4 pointers. We load the room based on the lines.txt. But to walk through how it works, when the game starts, and we create a map of string and room objects, load rooms, and this is just reading from the rooms.txt over here. So if we look at that, it has all of the rooms. It probably could have been a JSON. So they each have an ID, entrance, description, and this is so you can parse it, start and stop, and then items. So it should work if I add objects to this and items to these, and eventually an entity of a monster, which I don't have that yet. But let's add an item to the room and then we'll recompile it and see if it works. See, there's going to be torches, right? I guess that would be an item actually. In this game, the way I have it set up, item objects can be taken. Objects cannot, as far as like the game logic is. Anyway, it parses all this list. It calls load rooms, which is in the helper file here. Parser. Oh, sorry, we're wrong. Sorry, the rooms is what loads the rooms. Duh. Here, let's go to rooms.h. Yeah, somewhere in here we have our load room function, which is, it's going to return a map. Going to take the file name, which we sent, string, which is starting room ID. If we were going to make a save system, then we would save the last player room, which you saw here. It says saving game, but we didn't do that yet. And here, I guess we can go over the room object. So these are for, I had way too many includes, because I didn't need to forward declare these. So each room object that we make from the rooms text file and the load rooms function, each room has a pointer to the next room. There should just be a stack the player owns that points to the different rooms. They have a name description, which we create from here, from the rooms text file, name description. Although I don't use the name yet, but we could. So when it's created, everything takes a name description. When we kill it, we're going to go through and delete our vectors of objects, entities, items. Then we have our enter rooms, which are say description. That could probably be cleaned up to just not have two of those. I had a reason, I forgot. So they have functions to, hey, return an object in your room. If we're searching for it, is it there? We use it later on. Same for items. And at some point, I might have used this, is it in room? Then we have, this is what happens when we move. We exit, so it passes in left, right, forward, go back. If that exists, the pointer up here, if the pointer isn't null, then we return whatever this pointer is, and that goes into the player object. Else we null, and then there's a default output to the player. So yeah, so when we call load rooms, this is just a text parser. It was really annoying to figure out. We pass the file name, the ID, we make an internal map to return a map of a string and room, because that's what we want. And then we open a file stream. This is the only place I could find to do a try catch so far that would actually have like an exception that we care about. And instead of doing a if not file exception, this was interesting that there are fail bits on the file stream class. And so you can just set those, I think by default exceptions is nothing for the file stream, but you can turn those on. So the fail bit and the bad bit, which was fun, but then I found out that the end of file comes across as a fail bit, and then it was breaking. It wouldn't load, it wouldn't finish. Probably best just to do if not file. So yeah, so we try to open it, and if it doesn't happen, then we catch it, then we retry it. Give the player like, hey, well, if you moved it, give us a file. Which I just realized you could probably pass in any file and it would break. This would work. But then when we get down further for the string parsing, it just wouldn't make a room. No, I have an error for that. Okay. Anyway, we ask them to retry. Oh no, this will work. Yeah, we're returning the function which will return a map, and that's fine. Otherwise, it's gonna just say, hey, it's empty, and then the program will exit. We go to main if it is empty, because we return the map, we make it. If it's empty, it's like error, and the game closes. At first, I was trying to build all the room objects and set all the pointers at the same time. That doesn't work, obviously, because if I'm in room 1 and I try to set room 2 pointer, I haven't made the object for room 2, so there is no pointer. The pointer can't go anywhere. So instead of doing maps and exits, we do the map first of the rooms, and then we have the room exit struct, which is over. We have a struct to store the exits in, and when we're done, we'll call this on each object, and then set the exits based off the information here, which this is pointing to nothing. This is pointing to room 02, and it's going to find it. Since the key in the map is R001 or R02, it's going to know where the pointer is based on the map. Let's see. So we're done with loading. We have our exits struct. We have our map. Then we have our just temp variables here, and a vector for our names that we need to feed into the room objects if they have them, which we haven't currently done. This is long text parsing. I'm gonna go through that. So yeah, while get line if empty. If line is room, there's probably a better way to do rfind than that. This is like doing it backwards. Like find it and then start reading from the start of it. We're gonna count 5, which is gonna be room R. It's gonna grab this. So we loop through and we do that. If it's room, load it into current room ID. If we find name, current room name. If we find description, then we make in description true. We delete if we have one, because we will at some point. And then we keep doing that. Or we end if it's end, and if it's not, we're in it. We're gonna load. We're gonna keep reading the lines. And then we find all the exits. If it's an object, same thing. We're gonna make an object name, lowercase it. I should probably just not use cases, but oops. As long as it's not none, we're going to push back the name onto the vector, because we're gonna loop through the vector later to make the objects with the object factory over here. Same for items. If it's end, we make the room here. Rooms at ID is R, then exits at the ID is R, because we have the current ID. So we make the new map objects. And then we go through and make the objects if the object exists. Sorry, this is, we're making the object from the object factory over here, which takes an object, create an object from name. It's gonna take a string, it's gonna make an object. And I just wanted you to be able to pass either one, pass a name, whatever. Make it from name. Oh, sorry, this is an object type. I wanted you to pass an object type, which is an enum, which I have over here. Oh no, sorry, it's in my enums file. But there's an enum for all the objects in the game that you can do. So I could conceivably keep adding these. As long as I add an object over here with the logic, then it just works. We can test that, I guess. That's the plan. So we make an object from that, it returns it. If it exists, add it to the room object we have here. Oh, it's in the header. That's I see now why I think it shouldn't be in the header. Yeah, void add object. It's just objects.pushback. Objects is a vector when it's made. Anyway, back to this is just the parser to get loaded. So yeah, we do that. We create objects from the factory, push them into the vector, same for items. And then when we're done, this is just for one room. We clear everything. And so that will load all of the rooms into the map. And then we make a map of exits. We iterate over it, take the ID of the room is the first one, and then we're gonna loop through the rooms map via the ID, and then set our struct of the exits, which we made a struct up above. Yeah, the struct has the strings. So here's a fun one for the new thing, a lambda function. Still not exactly sure how it works, but it returns, and it had to be auto for some reason. It's like an inline function that you don't have to declare or define, just do it here. And the name is like find room, and you can pass things by reference or by values. You can tell a lambda to capture what you want it to capture. So this is pretty broad, but it's gonna take a string reference, which is the key, which we're gonna be passing it, comparing that to the ID. Empty or none, we don't care. Oh, because we have room object stored in the map. Map string rooms, iterator, room iter, rooms.find key. Key is this here. The room iter is not null. And we're not at the end, we're gonna return the second object, which is the room. Room pointer is this, which is the second object. Anyway, we have our rooms map. We put all the rooms in it, then we go through that, iterate, and we set all the exits. So now all the rooms point to each other. An improvement would be to make the player object have a stack. Anyway, we have the rooms now. That was the first thing to get started. Then we make a player object. We set up all of our look actions to use later. We see out the introduction. We set our current room in the player, create a struct of the parsed command, which we looked at in the parser, which is gonna consist of an action, verb, direct object, indirect object. And there's a whole thing on how the parser works. Main command, we just wanted something, so it's not garbage input. But while it's not quit, that's how you exit. We saw that down there. We're gonna get the command. If it's empty, nothing was typed, somehow they hit enter. You quit, we leave. Else we have something, so we parse it in the parser. And the parser real quick does string, so we make lowercase. I could have just done if a z, if more than a less than z. String, because they typed in a whole string, so we can put that string into a stream, just like a file stream. And we can just, every time we hit a white space, we're gonna push it back into a vector. And we return a vector called words. This is to take out all the prepositions. We're just gonna say yes if it is, then we're just gonna rip it out or ignore it. So the command type, this is just returning, like, if you tell me look, I'm gonna return an enum. That is a command type enum, which is over here in the enums file. So we're gonna pass the string, which is the player input. We're gonna make the struct. We're gonna lowercase it. We're gonna return the vector above, which is a vector of the words the player typed. If it's empty, we just go back and we saw that empty was, nothing was typed. We're assuming the first thing they typed was a verb, look, touch, one of the actions. So then we change that into an enum. So we push the enum on top, and from the vector we remove all of the prepositions. So I don't care. Just vector.erase, remove if. This was an interesting one to figure out. So you have like start, end, and then your condition. Yeah, and so if the vector is at 1, it was just a verb, so like look. Otherwise, it should be a direct object with like basic language, like look, torch, use torch. So then we put the torch into the DO, and if we kept going, like use torch on torch, then it would have 2 objects. Anyway, that's how we get the command. Text parsing is a nightmare. And then we're gonna switch on that enum. I wanted to use a switch, it seemed easier than if. So if it is an enum of look, if indeed there is no other words, the DO is empty, then it's just player.lookaround, which has like a default output. Else we do stuff. Object is going to be player, get the current room. The player is holding a pointer to its current room, so player get current room, which returns a pointer, room pointer, find object in room, and you pass it the word of the potential direct object, which is an object, could be an object like a torch, and it'll return a null pointer or an object. And then we're just setting an item here. We're just making an item real quick. If there is no object, then we assume it's an item. So item 1 is the same thing, player.getItem by name. we assume they're using it on themselves because you can't use it on a room. You can't use an item on an item. I decided there's probably a use case for that. And then look at whichever is true. If object, player look. If item, player look. And I had to do these weird calls. We'll get to that because they're overloaded and they're virtual. There's probably a better way to do that. Else, look action, do action, and pass the player and the direct object, which could just be a garbage string. So that repeats for every single action. Take action, use action has their own logic. If there's no second item, then you do the same thing. Object is find object. If it's null, then you assume it's an item, and then you do stuff. If there isn't an item, it's like you don't have an item, you can't use that because it didn't return the item. Because one is looking for the room, one's looking for player inventory. If the command is go or back, so goes the enum, and then the direct object in this case is going to be left, right, back, behind. We're switching on all these. Otherwise, you can't go that way, which we saw. That is happening by, if it is indeed true, player. We're going to change the player's current pointer. Set current room, get current room, and it's the left exit. Because the room has the exits, and the player's just holding a pointer to where they are. But back up to just like a simple look action that happens over in the action, base action, for declaring player object item class the action. Every action has a virtual here function called do. It's probably a smarter way to do it, but I wanted to have the do action be it. And I kept having different niche cases, use cases. So we have pass the player object every time because the player knows stuff about itself. I kept having, again, probably a better way. We pass an object pointer, item pointer, because you can use items on items at some point. And then a const of just garbage text if the player does garbage text, and then a virtual destructor when we destroy stuff. And they all have it in their header, and then the CPP file. So here's where the look action was happening. We're never going to pass two items, so that's just not happening. We just turn that off. If it is an object, we call object on look, and we pass the player. Because the objects, I decided something needs to know what happens, so the objects and items know what they can interact with. If the object isn't real, then we call look on the item. Else, it's just whatever the player said. Look at garbage. Or if it's just the word look, then we call player look around. So let's look at the player. And this is from me having way too many includes and getting collisions. So instead of declaring these, I did forward declaration. So the player, because at some point I wanted to add monsters, so they're all a subclass of entity. But currently the player is the only entity so far. So the player, we don't use health yet, but it has to be made with health. That's why we had health and a name in the main. We probably change that. Functions to set room, get current room, look around. This all the stubs here. So player gets it made. Look around is just return. You point to your room and the room just prints out the description. I could have done see out. I could have done it a different way, but currently if you just look around, that's what we saw earlier. Just the room says itself, which would be this down here. Set current room is when we move. If it checks if the room we pass, which we're getting from the go action. We can pull that back up. The go action says we got passed in. Oops. I think I did this a little bit hacky. Should probably do better. This should be in the action. Oh well. For now, it's here. So we're doing player set current room to our current room's left pointer. So we're passing in a pointer to the player object, and that pointer could be null because not every exit has something. So if it's not null, if it exists, then we go in there. At some point there will be a flag for like you can't, the door's closed or whatever, but currently you just walk around. If it's null, can't go that way. But that is briefly how the actions work. Everything knows what they do, so the player knows what happens on it. So let's check how objects and items work. Objects They all have an on use, on take, on open. All of the actions, like if you, they have a default of nothing happening. You hit it, nothing happens. You talk. They say their name. They return their type. And a lot of them are. All these are virtual. We can reuse them. They all return their type so that we can make them. We saw that earlier in the. I didn't show you, but in the object factory, in the rooms, when we made the room object, we're gonna make them. Either you pass in the enum here or the name. They both call this function create object because they both pass in type. Switch on type. I only have skull implemented, so if you pass me a skull, it returns a new object. We're gonna look at so what happens on an object. They all have defaults, and then the child's skull is a public inherits from objects. Could probably do this different, but they all take a name and a description. And I had to lowercase this because it was driving me crazy. On look, it gets, these are the stubs, returns itself, and the ones it overrides are currently on look. We saw the default was their description. Skull CPP's on look overrides that. So in this instance, when we look at the skull, we saw in main, look around. If we have a direct object, which we do, look at skull, so look skull. If object exists, look action, do action. So we're going to the actions, which is the look action, passing the player. So the look action, if you have an object, goes and grabs it tells the object how you're being looked at. In this case, goes down to the skull because it is base object but derives skull. And the skull has a flag, name and description from parent. It also has, every object has a used boolean. So the skull object is doing something, it's overriding the function to be more for its use case. So if that boolean is false and the item exists in the key, and for this one, if that exists in the room, because there's only one skull currently, see out what we saw earlier. Then we'll add that to the player's inventory. Player, because we passed in the player object get current room. Find the item in the room. We know it's a key because I told it. Then we make takeable. So the key wasn't able to be taken until I did that, and we can. Sorry, if we say look at skull, we take key doesn't work, and that's because in the key.cpp on take currently is takeable is false. So it says you can't take, that's why that's happening. But if we change the skull to, I wanted the player to look at the skull. So now they can. So now we saw the skull key.make takeable. So it's takeable. We can take the key. Anyway, so that's all that. And all the items have a base class. So the key is an item, and it's a base class of item. They get a name description. They have an amount so that if you take it in main, if you take the item, then it's going to do. You can only take items, not objects. So item equals player's room, find item. It returns an item. If that's real, take it, passing the player and the item, which would be take. We're passing in player an item, only one item. If that's real, item on take player, and player get current room. So we add it to the player's inventory, and then remove it. We tell the room to remove it from its vector. So we just move the pointer from one vector to the other. And then if it is an object, we still want to do stuff. So object on take would simply be it doesn't budge. So we still want to handle that use case. If other this default here, take what? And so that's how all the actions work. Let's see if what I said is true. If we can compile and put a item in the antechamber and a sword, a closet, and you know what? Let's put a box. Let's put a box in the room. So we'll put a box in this room. It's one of the actual things. Then let's compile it. So currently a lot of unused thingamabobs, because eventually, if I just add the room file and make the objects with their logic, then it just works because they're all already pointing to each other even though they don't exist. Oh, did I override it? I don't override it. All right. That's still, let's see if that still works. Take the key. All right. Does that still work? Okay. It changed. So let's go forward. And there's a torch, right? So look at torch. Oh, that's the default, right? Take torch. Hey, it works. Cool. Yeah. Yeah, we just added this to the inventory, or to the room. Cool. And that should now be gone from the room's inventory, so we can't take it twice. Awesome. Let's go right. So that puts us in room 3. And we added a sword, right? So look, it doesn't have a description though. This sword is on an object. That's not gonna work because it's a sword object. So that doesn't work because we didn't make the sword object. Okay, let's put this back to none. I mean, really fast, we could. Okay, so definitely cut all of that out. It took too long. We have added box to the room list. An item in the box which will get picked up in the room. That'll get picked up in the parser when it goes through the objects. We don't need this anymore. This was for debugging. A new object will get created. I had to add it object factory. Probably a cleaner way to do that. So now we have a box.h. We're just gonna override the look for now, but like I said, you add a new item to the thing, you give the item logic, it should just work. You put override, built it, so it should work. I left in the debug text, that's fine. This is printing out that when I compiled. This one has a torch. That was a new thing we added to the room 2. Let's go right. Need has a box. Look at box. See a box full of trinkets. So the default is just say the description. Description is a box full of stuff, but we overrode that here. So new object, as long as you make the object files, object factory, it works. Cool. So with all that, it should be able to make like the rest of the game, all the infrastructure set up. Probably to-dos for like room flags and room dot puzzle solves or something like that. But a lot of the basic infrastructure is there. That's long. That's it. So it could keep going. Most of this was making the infrastructure for the game. The majority of this project was making the room objects, the objects, the items, the player, the actions, making those all communicate and set the groundwork, the infrastructure for all of the fiddly stuff like a riddle and a monster as damage stuff. Okay. Hopefully that's good. Okay, bye.